Should we, um,
Quick.
should we study all quizzes too, or just?
No, just the test. All right here it says 10 and 11. It says use the change of base theorem. There was a problem earlier on this test where you actually used the change of base theorem. You didn't have to, but you could have. On these, you pretty much have to. There's really no way to solve this unless you know that change of base theorem. This is basically just using your calculator. But you have to know what to put in your calculator. You can't put this directly into your calculator, but you can do this little change of base. That's right, we don't have log base 5 in our calculator. But we do have log base what? 10 and base E. You could use either one. You could use log base 10 or log base E. It doesn't make any difference. You get the same exact answer. Let's just use the log. This is log base 10 if I don't put a base here. So we take this number right here, put that on top, and then this little base, we put that on the bottom. Okay, base, bottom, it's easy to remember. You follow me? So it's log base 10, or a common log of 18, over log 5. And you just chuck that in your calculator and get an answer. Somebody have a calculator on? Let me,
1.7959.
okay. Alright, let's just see how to do that just real quick here. That was my other stuff. Alright, so log 18, so it's log, let me use the mouse for that. It's log 18. We'll close it, I don't know if we need to. Divided by log 5, and there it is, 1.795. And it says to round to 4 decimal places, so it'd be what? Yeah, 7959, right? 1.7959. Alright, simple as that. Make sense? It's easy, right? Next one's not much more difficult. It's just you have a fraction. That's not really that big of a deal. So let's do this. Just for fun, let's go natural log, just to show you that it doesn't matter if you use the regular log, the common log, or the natural log. So let's put this on top. What are we putting on top? That number right there is 5 halves. Okay, so we put 5 over 2, and then, right, ln, and then 5. Now if you're going to use the ln, you got to use the ln for both of them. So let's see what that looks like. So let's go natural log right there of 5 halves, 5 divided by 2, alright, and then divide that by natural log 5, and close parentheses, and there we go. And so your answer is 0.5693 if you round it to 4 decimal places. It's pretty easy, isn't it? I mean, that's really quick. You should know how to do that. It's not that hard. You got to know this theorem, and then it's just all calculator work after that. All right, let's move on. All right, let's take a look at this. This is one where it seems like a lot of people mess up on this, but let's get it now, all right, so we remember it for the test. What we have here is we have this plus. That's what I see right off the bat. I see a log plus another log. What does that tell you? We had a rule, called it the product rule. We call it the product rule because it's multiplication, right? We take addition of these two separate logarithms and we make it into multiplication. We put one logarithm out in front and we multiply these things together. But before we actually do that, we want to do something else. What is that? The exponents, right. So remember this, we call this the power rule. We're going to take that 1/3 and put it up here. We're going to do the same thing with the 1/2. We're going to put it up here as an exponent. If you're not sure where that is, look at chapter 8 and find it. It's in there, okay? I'm not teaching this stuff from scratch. I'm just showing you how to work the problems, assuming you know these rules, okay? And what do we get here? We get log base 5 of 64. Now, I'm not doing that multiplication thing that we talked about right off the bat. Okay, we're going to change these, do the exponents first, and then we're going to get ahead and make this a multiplication problem. So it's 64 to the 1/3, and then it's plus log base 5 of 49 to the 1/2. Now, you don't really do anything to that. We're just going to tag this along down here on the bottom. Let's see what we can do now. This is 64 to the 1/3, which is the same thing. It's the cube root. That's right. It's the cube root of 64. What is the cube root of 64? It's just 4, right? I mean, that's a number that you might be able to do in your head. If not, use a calculator to figure it out. So I'm going to show every step here. So it's log base 5 of what? 4 plus log base 5 of what? 49 to the 1/2 is the square root of 49, which is just 7. Right? On the left-hand side, we still haven't done anything with that, have we? Over here, now we can apply this rule, okay, because there's nothing out in front of the logarithms. It's just log of A plus log of B. If you remember what we do, we just put one log out in front. Right? Now, this only works if these are the same bases, and they are. We one log out in front, and what do we do to the 4 and the 7? We don't add them. What do? We multiply them together. So yeah, we could just write a 28, but I'm just showing you where we get the 28 from. Now if you look at this, the log of this side equals the log of that side. The log of this equals log of that, so this equals that. So n equals what? 28. That's it.
We can have the fractional exponents aside from the easy ones like half power.
There was one earlier on number 8. So go back and look at this on number 8. There is a fractional exponent that's not just a 1/3 and a 1/2. Yep. All right, here's another one that's very similar to it, but now instead of a plus in between them, there's a minus. So the plus means that you multiply them together. A minus obviously means what? That you're going to divide. That's right. There's nothing in front of these logs right here, so I don't have to worry about taking anything and putting it up here as an exponent. So I'm just going to write it as a division problem. I'm going to put one logarithm, log base 6, and I'm going to take these two things right here, this parentheses and this parentheses, and make a division out of it. So it's going to be 5 minus 2a. The first one always goes on top, the second one goes on the bottom. And that just equals 1. Everybody see what we did? That's called the quotient rule. Look it up on chapter 8 if you're not sure where that came from. Now we have this situation right here. Now the logs just don't cancel out this time, do they? Because we don't have a log over here on the right hand side. But I do have this in logarithmic form. What do you think is one option here? To change it exponential form. That's right. So we could go what? I always like to go 6 to the first, right, which is 6, equals what? This thing right here. So let's write it like that. I just kind of slid it, put it on the left-hand side just because I like the variable on the left-hand side. Semicircle? I guess. I never called it that or anything. You could think of it that way. Whatever way works for you.
Yeah.
As long as you set it up like this. 6 to the first equals this. Okay? That's how I think of it. Again, we talked about this earlier on the earlier video with this chapter. So you can look at, we even put the original formula down, changing from one form to the other. If you want to look at it, you can. Now we just have to solve for a. So what I'm going to do here is I'm going to multiply both sides by 3a, right? That'll get rid of it here. So multiply that by 3a, and then let's just solve. Now it's just basic algebra. That's 18a. Let's see, added 2a, which is going to give you 20a, and that equals 5. Wow, what's going on over there? Divide by 20, and so a is what? 1/4. Alright? Let's make sure that, remember, when we take the log of something, we call this the argument. The argument has to be what? It's got to be positive. So if I put a 1/4 in there, does that still make it positive? Yeah, because 2 times a fourth is 2/4, which is 1/2. 5 minus a half, that's still going to be positive, isn't it? Alright? And if you put it in here, that'll work as well. So that's perfectly fine. That's our answer. Time? Alright, here we go. Same idea as we did just 2 problems before. We see that plus, we see log, so we're going to make that multiplication. So let's do that. So it's log base 3. I'm just going to put one log out in front, and I'm going to take these two things right here and just multiply them together. So it's going to be x minus 3, x plus 2 equals, don't really do anything over there, it's just log base 3 of 6. Look, don't try to change this and change a base theorem and get a number for it. Why not? That's right. The log 3 goes with the log of 3, so basically I just set these equal to each other. Alright? So now let's multiply these together. What's that going to be? It's going to be x squared plus 2x minus 3x, which is minus x, and then minus 6, and that equals what? 6. Subtract 6 from both sides. It's a quadratic, isn't it? So it's negative x what? Minus 12 equals 0. See what I did? Subtracted 6 from both sides. Now we want to solve for x. It's a quadratic. I guess you could use the formula, but this works real nice and easy. We can factor this, can't we? So I always try to factor if it's possible. And then they multiply to be negative 12, adds up to be negative 1. So that would be negative 4 and positive 3. Set them both equal to 0. We can do this in our head. Set them both equal to 0, solve for x. So x is what? 4, and x is negative 3. Now, before we circle them and say they're our answer, what do we have to do? You've got to check them. You've got to make sure that it's going to make this into a positive. What about 4? If I put a 4 in there, does that stay positive? Yep. Does it stay positive here? Yep. What about negative 3? It's not going to. Now, look, it's not that the fact that it's a negative why it doesn't work, because there are some problems where your answer can be negative, you put it in and your argument's still going to be positive. Does that make sense? So it's not the fact just because it's negative. Unfortunately, they give you so many examples where the negative answer is always the one that doesn't work. But there are times when you can get a negative answer and you can put it in here and that would be okay for x. But in this case, it's not, is it? I put it in here, it makes it negative. I put it in here, it makes it negative. It doesn't matter if one makes it negative and one makes it positive. If it becomes negative at all, it's not going to work. So we don't include that. So we circle that, and that's our only answer. You cannot include both of them because that does not work. Negative 3 is not a possible solution. You can't include it. You cannot. I should say that. You cannot include negative 3. We good with that? All right, let's move on.